Question number 5A says, Mr. Morgan administered a spelling test to his class. The table below shows the number of words out of 10 that each student spelled correctly. So I wonder how many students are in this class. I guess N would be equal to the sum of the frequency. I don't know if this is going to be necessary, if we're going to need this figure, but we're not going to need it. But let's just add it up. This is 12 and 4, 16, 20, 23. 12, 16, 23. Looks like 23. So there are 23 students in this class. For the data set above, state the mode. Well, the mode would be the value with the highest frequency. The mode would be the value with the highest frequency. The highest frequency is 8. So the mode so the highest frequency is actually 8. So, and that corresponds to the value 5. So the mode is 5 correct words. The median. Now, the median, once you have so once you're dealing with ungroup data and you have to find the median is value number n plus 1 over 2. Well, we added this up already and we got n to be what? 23 plus 1 over 2. So the median is the 12th value. So we need to know which value is the 12th value. I think the answer is 6. But to get that now, I need cumulative frequency. So for this level, the cumulative frequency is 8. Now 8 plus 4 is what? 12. Cumulative frequency means that you're going to add the frequencies. 12 plus 2 is 14. 14 plus 2 is 16. 16 plus 3 is 19. 19 plus 4 is 23. Here's how it works. So the first 8 value is what? The first 8 values are 5. Now the 9th value to the 12th value is 6. The 9th value to the 12th value is 6. Now that is important because the median is the 12th value. So the median Q2 is equal to 6 correct words. We're to calculate the mean. Now, to calculate the mean x bar is equal to the sum of fx over n. So fx is frequency times value. So let's put in fx. It's frequency times value. So it's 8 times 5, 40. 4 times 6, 24. 2 times 7, 14. 2 times 8, 16. 3 times 9 is 27. 4 times 10 is 40. I also need the sum of fx because remember the mean is the sum of fx divided by n. Please bear in mind, fx is the frequency times the value. So let's get the sum of fx. That's 40 plus 24 plus 14 plus 16 plus 27 plus 40. This looks like it's 161. Let's double check. 40 plus 24 plus 14 plus 16 plus 27 plus 40. 161. The mean x bar is the sum of fx, 161, over n, which is 23. And the mean is 7 correct words. All right. Now we're at the B part of the question. The B part of the question says, the attendance officer at a particular school recorded the time, T in minutes, taken by each student in a group to travel to school. The data collected is shown on the cumulative frequency curve below. All right, so it's a time taken for each student to get to school. This is 220 students. All right, and using the cumulative frequency curve, find an estimate for the number of students who took at most 32 minutes to travel to school. So the first thing I need to do is to find out which student took 32 minutes to travel to school. And so at 32, I'm going to draw up a straight line. And where it hit the curve, I'm going to draw a horizontal line. So what is this telling me? This is saying to me that student number, this is how much? Over to the left, it's going up by what? 5? Or by 4? 5, 10, 15, 20, it's going up by 4. So this is 44, 48, 52, 52 plus 2, 54. This looks like 54. So the 54th student took 32 minutes to get to school. The 54th student took 32 minutes to get to school. I guess if you said 52, 52 looks like it's just as accurate. I think I prefer 54 for me. But I think if you actually said 52, I think you would get it. So the 54th student took 32 minutes to travel to school. Everybody below him took less than what? 32 minutes. Now, what I want are the students who took at most 32 minutes. Now, at most 32 minutes means 32 minutes or less. So the number students where the time is less than or equal to 32 minutes is, for me, 52 students. Sorry, 54 students. 54 students. All right, sometimes the examiner milk a question. This is one of those milk questions. Next, he needs the interquartile range. The interquartile range. To get the interquartile range, our interquartile range IQR is equal to Q3 minus Q1. Now, Q3 is value, is the time taken by student number quarter of n. Now, n is all the way up at the top here. So n is equal to 220. A quarter of that is 220 divided by 4 is 55. So student 55, yep, I don't think I'm going to get it more accurate than this. Student number 55, this value here would actually be my Q1, because I'm not going to get student 55 exactly on this. So student 54 will have to work for me. So Q1 is 32 minutes. Now, Q3 would be the time taken by student 3/4 of n. So 3/4 of n, which is n is 220. 3/4 of n is student number 165. Student number 164 is exactly on this line. I don't think we're going to get it any more accurate than 164. So what that looks like is it looks like somewhere around here. This value here would be my Q3. And my Q3 appears to be 54 minutes. 54 minutes. Q3 is 54 minutes. So my IQR would be 54 minus 32. This appears to be 22 minutes. C says the letters in the word positivity are each written on a separate card on separate cards and placed in a bag. This year picks 2 of these cards at random with replacement. Find the probability that she picked the letter I and then the letter V. First of all, let's count the number of letters. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters. Now, there are a total of what? 1, 2, 3 I's. So the probability of getting an I is equal to 3 out of 10. And the probability of getting a V, there's only one V, is 1 out of what? 10. Now, selecting an I and then a V with replacement, the act or the event of selecting an I and the event of selecting a V are independent events. 2 events, I and V, are independent if the probability of getting an I is not influenced by the probability of getting a V. In this case, a probability of getting a V is not influenced by the probability of getting an I. And so getting a V, the events of selecting a I and a V are independent events because the event of getting a V is not influenced by the event of first picking an I. And the reason they're independent is because After Dacia picked out one of the I cards, she placed it back in the bag because we're told that this is with replacement. With replacement means that she puts it back. Now, if she had taken it out, it would have been only 9 cards left in the bag. And so the probability of getting a V would not have been 1 out of 10. It would have been 1 out of 9. So the fact that she replaced the card after she took out the I, looked, saw it as an I, and put it back in the bag, the fact that she replaced the card, probability of getting an I and then a V are independent events. And if 2 events are independent events, the probability of getting an I and then a V would be equal to the probability of getting an I multiplied by the probability of getting a V. And this would be 3 out of 10 multiplied by 1 out of 10. The probability is 3 out of 100, or 0.03, or 3%. So there's a probability, the probability of getting an I and then a V, given the fact that I replaced the I after I got the I, the probability of getting an I and then a V is 3 out of 100, or 0.03, or 3%.